Okay, we're going to look at another question from thermal properties. This question is from 2012 paper 2 section A, question 5. So this question, let's read the question together. A liquid at a temperature of 100 degrees is placed in a test tube. The sample is allowed to cool for 120 seconds in a laboratory where the temperature is 20 degrees. Alright, so the keywords are, number one, it is a liquid from the start, and number two, the temperature starts from 100 degrees and is cooled to 20 degrees. So state the time that the sample becomes completely a solid. So this question is quite simple. First, we know that this is a cooling curve, so this is going to be liquid, while this will be liquid and solid. So liquid and solid is actually the process of freezing, while this will be solid. So from here, we know that the freezing, the point where it turns to solid will have to be at this point. So when you read this point, you need to read it very accurately. So it's going to be half of a division. So if this is 80, this is 100, this will be 90, this will be 100. So that means each small division is 2 degrees. So 92, 94, 95. So the first answer is 95 degrees Celsius. Okay, you need to be very, very precise in your reading. The second question is a bit interesting. State why the sample is losing thermal energy throughout the experiment. So we need to know that when temperature is decreasing, alright, energy is given out. The other thing is when temperature is freezing, energy is also given out. So by stating these two facts, you already demonstrated that the thermal energy is being released, because number one, temperature is decreasing, number two, liquid is freezing. Alright, so the next thing is that explain why, alright, the temperature in the sample is constant for some time even though the thermal energy is lost to the laboratory. Now this question, before I show you the answer, we need to address a very common mistake. Now the common mistake is this: many students like to just recite from the textbook and they only copy a certain passage which is only for a certain context. Now let's read this mistake first. Heat energy absorbed is used to break the bonds holding the liquid molecules together instead of changing the kinetic energy. So this is a very typical answer that students like to recite. But this is only applicable if this question is a question on melting. Alright, but unfortunately this question is not a question on melting, but on freezing. Alright. So what is the difference between melting and freezing? Very simple. They are opposite process. If they are opposite process, you cannot say that, number one, you cannot say that energy is absorbed. Because if it's opposite process, instead of absorb, energy is released. So this is the first mistake. The second mistake is that instead of breaking bonds, it is to form bonds. So this is another mistake. Alright, so instead of answering this way, alright, you need to contextualize the question to this particular case. So context is king. Remember, context is king. So heat energy is released is due to strong intermolecular bonds are formed as a liquid freezes into a solid. So the bonds are formed, okay, and the energy is released. So be careful. These are the things that we are looking for. And instead of a change of kinetic energy, the potential energy decreases because it's a change of state. Okay, so that's how you should answer this question. Alright, so next, let's look at the last part. A test tube containing an identical sample of liquid at 100 degrees is placed in a beaker of water and is kept at 90 degrees. Sketch a cooling curve. So first, you need to know that this water is kept at 90 degrees, so this temperature will never change. Number two is that the temperature difference between 100 and 90 degrees is much lesser. So you will expect that the cooling rate is much lower. So because of that, we need to know, number one, the cooling rate is much lower. So this curve is going to be a lot gentler. Alright, and then number two is going to only end at 90 degrees. So if I'm going to resketch this curve, it's going to start here, but it's not going to have the same steepness of as this slope, but it's going to be much more gentler, and then it might even reach the steady state at a later point. Right, then after that it will be steady throughout. So that will be your answer. Alright, so this is the answer for the whole question.